Okay, hi, how you doing? We're going to talk about how it is that I find theta on the interval of 0 to 360 when I'm involving a double angle and a single angle. And what I want to take note of here is that I have a squared single angle. So we're going to talk about, things that we have to avoid and be careful of doing. So first things first that I'm going to look at is that I've got a single angle and I've got a double angle. Now I can't exactly turn a single angle into a double angle, but I can turn a double angle into a single angle. And when I saw these, remember from my prior videos I was talking about that you have to have it all in the same type of angle before you can go ahead and start solving these things and manipulating to do what you need them to do. So this sine 2 theta, I'm going to go ahead and use a trigonometric identity that puts it into a product of its single angles. So sine 2 theta is the same exact thing as if I had 2 cosine theta times sine theta equals, so 2 cosine squared theta. Okay, so what I've basically just done is I literally just took the double angle and wrote it as its single angle identity. The important thing from here is that we got to be careful because yes, while I'm supposed to solve for a trigonometric function here, what you really want to be careful of when you solve these things is that you don't want to reduce the powers of things. So I have a 2 cosine squared theta here and I have a 2 cosine theta sine theta. Well, natural reaction for me would be to divide both sides by 2 cosine theta, and then you're left with sine theta and cosine theta being equal to each other. But the thing about that you got to be worried about is that right now this is a squared, and a squared means that you're going to have more solutions. So if I take something out of its being squared and put it into its linear context with an exponent of 1, I've somewhere along the way have just by doing that property gotten rid of some of the answers and the solutions. So I've gotten some things mixed up and lost along the way. So we're going to talk about what are some things that I can do. So what I'm going to do is I'm going to think about this as if it were just a quadratic, because I have my highest exponent is a 2. So thinking back to algebra 2, okay, what did you do with quadratics? Well, you set quadratics up to equaling 0, and then you went through some factoring processes to figure out what could I do. So I'm going to do that same type of thing. So what I'm going to do is I'm going to subtract 2 cosine theta sine theta from both sides. And what I get left with when I subtract it from this side is 0. So I'm going to be left with 0 equals 2 cosine squared theta minus 2 cosine theta sine theta. So what I now have here for this particular function here is that I've got 2 cosine theta squared minus 2 cosine theta sine theta. So now I'm going to go ahead and try to do some factoring things here. So what I notice is that each term here has a multiple of a cosine theta and a multiple of 2. So I'm going to go ahead and factor that out. So I'm going to get here 0 is equivalent to 2 cosine theta, okay, times, well, 2 cosine theta times what gives me 2 cosine theta squared? Well, that's just a cosine theta, okay, minus, so if I take that out, I'm just left with the sine theta, minus sine theta. So now what I have here is a very important process of something that I'm going to do, and that is that I now have this set up, which was a subtraction problem, was a difference, is now set up as a multiplication. So what I can go ahead and do is I can say, okay, the factors of this both must be 0, and if I can figure out what those factors are, then I can go ahead and say, okay, this is what it must be. So to go ahead and do that, I'm going to say that 2 cosine theta must be 0, and I'm going to go ahead and say cosine theta minus sine theta must also be equivalent to 0. So now that I've done that, what I can go ahead and do here is I can say, okay, this one particular function, I now have that, okay, well, cosine theta must be 0. Divide both sides by 2. So when does theta give me an output for 0? So when is cosine theta equivalent to 0? And we know that theta is equivalent to 0 when cosine is at 90 degrees or it is at 270 degrees. So the next thing that I want to talk about here is that how on earth am I going to solve cosine theta minus sine theta equals 0? So I'm going to go ahead and at this point I have nothing to do. Okay, the only thing that I can think of to do here would be go ahead and say, okay, what am I going to do? Well, let's try going like cosine theta, okay, and add sine theta to both sides. So I'm left with cosine theta on that side. So now I have cosine theta and sine theta. So now what I'm going to do is I'm going to divide both sides by cosine theta. And the special thing about that is that produces me a value of 1. And 1's a very important number in mathematics. If I can produce 1, that's sometimes what I want to produce. So now I look at this and I go, okay, this particular function here, if I take a look at it, well, that makes 1. So if I divide this, okay, go ahead and divide it by 1. All right, so I go ahead and I divide this by 1. I'm going to be left with that this particular function then is divided by cosine theta divided by cosine theta, and I'm left with 1 is now equal to, well, sine theta divided by cosine theta is tangent theta. So now I have tangent theta. So what angles is tangent theta equivalent to positive 1? And tangent theta is equivalent to positive 1 when theta is 45 degrees. So 45 degrees, using that as my reference angle, what quadrants is tangent positive in? Well, it's positive in quadrant 1, and it's positive in quadrant 3. So using that as my reference angle, I get that my theta at the end could be 45 degrees. I get that it could be 90 degrees. I get that could be 270 degrees. And my last final theta that I could have for this particular problem is 180 plus 45, which is 225 degrees. So for this particular function, what I have here is I've gone through and I've rooted out all the possible answers. So again, what I want to talk about very quickly here is the importance of is that I don't want to do division, okay? You want to avoid division. You want to think about this in the sense of going back towards how would you solve quadratics? Well, you would set them equal to 0 and then solve for it from there. Okay, there's a couple other ways I could do this particular part here. I could have said, okay, I'm going to multiply both sides by cosine squared plus sine squared and gone from there and use some of the things, but this way I think is probably the quickest and easiest, so I went with this route. I'll put up another video and I'll just call it the ending to this one, so if you want to see the ending of how it is that I could change this into something else, I'll go ahead and do that for you as well. So you can choose which way you like best. So I hope that helps.